Okay, I'll share the screen where we have left. So we were implementing the transmission gate XOR using transmission gate. I'll also give the attendance also the chat box. So I told you that when I start the recording, give the attendance in the chat box. So बाद में दिया है कि नहीं दिया, attention खत्म हो रहा है. Should implement that. So we have based on the truth table, we have started to draw. So you know that the output is going to be your B or B bar based on the input A. I'll take the color. So based on the, you can see, based on the value of A, the output could be B or it could be B bar. So you know that output will be B when your A is 0. So when your A is 0, so obviously I want this abort transmission gate, abort TG should be on and this should be off when your A is 0. So A is 0 means what we can do, we can connect here. So obviously this will be your A bar, because we want A 0 पे ऑन होना चाहिए ना. तो A अगर 0 दूंगा तो ये A bar will be 1. So ये NMOS को ऑन करेगा और ये मेरा A रहेगा, है ना. Because A 0 means directly ये इसको PMOS को ऑन करेगा and output will be A. Now when my A is 1, so below वाला ऑन होना चाहिए, below वाला ऑन होना चाहिए, because you can see here A becomes 1 तो ऊपर वाला ऑफ हो रहा है क्या, ये चेक करो पहले. So now A becomes 1, so obviously A becomes 1, तो यहाँ पे PMOS को ऑफ करेगा और ये 0 हो जाएगा तो NMOS को, हाँ तो ऊपर वाला ऑफ हो रहा है. So A is equal to 1 we have to give. So A is equal to 1 means this will be A and this will be A bar. So नीचे वाले को ऑन कर देगा और हमारा आउटपुट B bar हो जाएगा. So this is simple implementation. तो इसका थोड़ा सा अभी A और A bar कैसे निकाला इसके लिए हमने एक थोड़ा सा this one implementation है. So you can see here, this is your B bar. यहाँ पे आपका B bar आ रहा है ना. You can see this is your B bar and here you have B. So I want this B to be passed to the output when your input is A. So now you can see the input is A is 0. So when A is 0 मतलब ये A directly यहाँ पे connect किया और इसका invert किया A bar इन दोनों को connect किया. So you can see here same implementation. A bar यहाँ पे और A यहाँ पे NMOS PMOS को और यहाँ पे NMOS को. So same implementation. So you can see here we're connecting here A and here A bar and this is also A, है ना. तो just एक inversion लगा के आपको this पूरा properly implementation किया है. So the diagram which I drawn in the previous slide is same. This मैंने इतना ही draw किया this part, है ना. I have drawn this much part. इसलिए इतना part draw किया मैंने से. Correct. This much part only I have drawn. So, but in exam you can draw this one also or half भी चलेगा, कोई issue नहीं. Okay. So this is the XOR using transmission gate. Now we can implement the 4:1 multiplexer also. That is also there in the syllabus. So we have to do that. Now how many transistors will be required in here? If I using CMOS, they are saying 8 transistors. Can anyone tell me fast how it is 8 transistor? 8 transistor CMOS transmission gate implementation for the XOR function. So can you just let me know why it is 8 transistor? Here you have 8 transistor utilized. Can just anyone tell me why it is? Be fast. If you know the answer, if you don't know, don't worry. We will do that. But if anyone knows the answer, please let me know. Or you can unmute, you can say fast. Why it is 8 transistor? Anyone knows? Please reply. Anyone knows how it is 8 transistors? It is saying that you can see the statement 8 transistor CMOS transmission gate implementation. So just let me know how it is 8 transistor, because you can see here 2 transmission gates. So, based on that, how it is 8 transistor, I can see, or we can see only 4, because here you have 2 transistor for one TG, one PMOS, one NMOS, and 2 transistor for another TG, which is one PMOS and one NMOS. So 2 to 4, 4 transistor hai. But we have 8 transistors. So can this anyone let me know why 8 transistors are given here? This is not wrong. This is correct. We have 8 transistors, but can anyone tell me how, where are remaining 4 transistors are there? आशीष, समझ में आया? आवाज आई? Okay. So let me know how it is 8. If anyone knows, just unmute करके बोलो. Type मत करो, कि type में time जाएगा. Sonal, Shreya, Saim, Dashrath, anyone who knows. Ashish, Gaurav, Gopal, Nikhil, Nutan, Raghuraj, Rashid, Musab, anyone, just let me know if you know the answer. Okay, I think no problem. I'll explain you that. Now see here, we have 2 inverters also. You can see this is inverter 1. Right? It is, we are using CMOS. So obviously, one inverter means 2 transistors. Similarly, this also going to use 2 transistors, one PMOS and one NMOS. Similarly, here also one PMOS, one NMOS, one P and one NMOS. Because we are using CMOS. So remember that one, when you are having one inverter, तो इन्वर्टर को भी एक CMOS लगता है, because CMOS is a inverter, so वो input को invert करता है. So one CMOS is consisting of 2 transistors, one PMOS and one NMOS. So this inverter is actually we are implementing by CMOS, so obviously 2 transistors. Similarly here also 2 transistors. So total is 8. 4 for 2 inverters and 4 for 2 transmission gates. I hope you have understood. Everyone. This is also 2 transistor and this is also 2 transistor. Maybe my voice is in between breaking because I'm getting the message that your internet is unstable. So is it clear now? Are you able to hear me, everyone? Or still it is breaking? Okay, still it is breaking. Okay. So just let me know, have you understood this one? How it is 8 transistors? Just confirm that. So we can go to the next slide and okay. Okay, Ashish, no problem. So you can see here how it is 8 transistor. Now you can see for the, we have 2 transmission gates. One transmission gate is this one. So obviously this is your PMOS and this is your NMOS. So 2 transistors for one transmission gate. Similarly, 2 transistors for another transmission gate. So this 2 becomes 4 transistors. Then we have inverter also. Rashid, mute yourself. Okay. So we have inverter also, and we know that inverter means simple CMOS. So CMOS may we have one NMOS and one PMOS. So how many transistors for one inverter? 2 transistors, one PMOS and one NMOS. Similarly, this inverter is also, we are using CMOS, so one PMOS, one NMOS. So 2 transistors for one inverter, another 2 transistors for another inverter. So like that way, 2 transistor becomes 4 transistors for the inverter and 4 transistors for the transmission gate. So it becomes the 8 transistor for the total XOR using transmission gates. Okay. So now we can go ahead and when we implement 4:1 mux. So you know 4:1 mux means you have 4 inputs and 1 output. So based on the 4 inputs, how many select lines will be there? 2 select lines. You can say S0 and S1. And yesterday also, means in the last lecture or today in the morning session also, we have seen the 4:1 mux. Truth table also, you know truth table when your S0 and S1 both are 0, A will be passed. When S1 is 0 and S0 is 1, B will be passed. When S1 is 1 and S0 is 0, C will be passed. And when your both is 1, D will be passed. So based on selected and your particular input will be connected to the output. That is the logic. So here you can say when your S0, when S1 is 0, your A and B will be passed. When your S1 is 1, your C and D will be passed. Because when you can see here, when S1 is 0, your S0 and is changing in both ways. Similarly here also it is changing both ways. So obviously S0 we are going to give one transmission gates. So the implementation you can, so obviously here you can say 4 outputs are there, 4 states, 4 inputs are there, so 4 transmission gate हमको लगेंगे. So I can simply draw in a faster way. Actually I have drawn already in the next slide. Your transmission gate है तो. So here you'll have A, then B, then C, then you have P. Correct. Then these lines I will just delete it afterwards. So you know A will be connected to S0. So here you'll have simply S0, and this one will be S0 bar will come here. Correct. No problem there. So you just delete it. Here it should be S0 bar. And here also is complementing. So यहाँ पे बार नहीं आएगा सॉरी, बिकॉज यहाँ पे S0 बार आना चाहिए, बिकॉज A को ऑन करना है. दिस शुड बी विदाउट बार. B के लिए क्या होगा, नीचे NMOS को देखना है तो PMOS को उल्टा कर देना. NMOS के लिए यहाँ पे S0 आना चाहिए, तो ये S0 बार हो जाएगा. फिर C के लिए क्या है, S0 NMOS S0 0 है, तो S0 0 मतलब हमारा NMOS के लिए बार हो जाएगा. तो यहाँ पे आपको S0 बार, so this will be S0. करेक्ट. एंड सिमिलरली D के लिए यहाँ पे S0 आएगा, तो this is S0 bar. So I have implemented this. The output will be given to the S1 now. Now you can see here this is implementation. And you can understand this. So you can see A is given here, so S0 is 0 bar, because when your S is equal to 0, now you can understand here, when your S0 is equal to 0 and S1 is equal to 0, correct? So what is your output? So when your S0 is equal to 0, so what will happen, you can see the above transistor will be on, because S0 is 0. So S0 bar will be 1, कि NMOS को on करेगा और ये भी on हो जाएगा. So for above वाला will be on, while this one will be off because S0 is 0, so ये NMOS को off कर देगा. So ये off हो जाएगा, you can see cross here. Similarly, this will be on and this will be off for S0 is equal to 0. So यहाँ से आपका A आ जाएगा, यहाँ से C आ जाएगा. You can see A and C is coming here with the green color. So A and C for the first case. Now again your S1 is 0, so when S1 is 0 means S1 bar will be 1, so ये NMOS को on करेगा, and S1 this is 0, so ये and ये इसको off कर देगा. So your output will be A. So I think you can understand same way the other conditions. So important thing is to what are this control signals connected. इम्पोर्टेंट यही है कि किसको S0 देना है, किसको S0 बार देना है। सो आपको पता है कि A इज गोइंग टू बी देयर फॉर S0 इक्वल टू 0। तो S0 इक्वल टू 0 मतलब nMOS को उसका बार देना है, याद रखना। करेक्ट। So the operation you can understand it is same way how the operation is there for the transmission gate, pass transistor. So same operation is there. Just आपको याद रखना है कि nMOS आपको ऑन करेंगे तो उसका कॉम्प्लीमेंट आपको PMOS को देना है। बिकॉज यू कैन सी हियर यहाँ पे S0 बार दिया है तो यहाँ पे S0 दिया है। यू कैन सी S0 यहाँ पे दिया है तो यहाँ पे S0 बार है। मतलब ये दोनों कंट्रोल सिग्नल्स कॉम्प्लीमेंट ऑफ ईच अदर, दे शुड सेटिस्फाई। ये S0 है, यहाँ पे S0 बार है, कैन सी S0 बार। सो nMOS से ले रहे हैं हम लोग, S0 बार है तो यहाँ पे S0 आना चाहिए, यहाँ पे S0 है तो यहाँ पे S0 बार आना चाहिए, लाइक दैट। सो आई होप यू हैव अंडरस्टूड द ट्रांसमिशन गेट implementation for 2:1 mux XOR and 4:1 mux. Then similarly you can implement for AND gate. Any expression if it is given to you, AND gate, OR gate, NAND gate, you can do that. करेक्ट। NAND गेट करना है तो आप ऑब्वियसली आपके आउटपुट को वापस CMOS लगाना पड़ेगा। मतलब यहाँ पे एक इन्वर्टर लगा दोगे दिस आउटपुट। अगर सपोज इसको इन्वर्ट करना है तो जो भी आउटपुट आएगा उसको इन्वर्टर लगाना पड़ेगा। सो यू कैन गेट दैट NAND, मतलब बार लेने के लिए आपको इन्वर्टर करना। ओके, सो दिस कंप्लीट्स द ट्रांसमिशन गेट। So this is completed. So finish that. Okay. Then there is a pseudo-nMOS that we will do in the next lecture. Okay. So this part will start with the on the next lecture. So I hope you have understood. Pseudo-nMOS is like the concept is very simple. We can finish it within 5 minutes also. Because यहाँ पे simply आपको क्या करना है, you can see with the circuit diagram. Pseudo-nMOS क्यों बोलते हैं? बिकॉज आपका nMOS सेम है CMOS का कॉम्बिनेशन। यू कैन सी nMOS सेम, क्योंकि यहाँ पे अगर आप एक्सप्रेशन निकालोगे सो P आउट इज C1 इंटू B1 प्लस B2 इंटू A1 प्लस A2 प्लस A3। आउटपुट एक्सप्रेशन यही है एंड विद द बार साइन, ऑब्वियसली बार रहेगा यहाँ पे। इंटू मतलब इसी के आगे है, याद रखो। सो बट आपने क्या किया यहाँ पे PMOS की जगह पे, यू डोंट हैव द PMOS होल नेटवर्क, आप एक ही PMOS कनेक्ट करते हैं एंड दैट इज ऑलवेज ऑन। PMOS ट्रांजिस्टर एक्टिंग एज अ लोड। PMOS मतलब हमेशा ऑन रहता है। सो दिस इज अ सूडो nMOS। तो इसके से क्या होता है, नंबर ऑफ ट्रांजिस्टर इन दिस एडवांटेज क्या होगा, द नंबर ऑफ ट्रांजिस्टर इज लेस बिकॉज यू आर यूजिंग ओनली वन PMOS। nMOS जितना आप जैसा CMOS में करते थे वैसे का वैसे ही रहेगा। So number of transistors for nMOS will be same, but for PMOS it is reduced. So number of transistors will be less, so area occupancy will be less. But there are many disadvantages that your W by L ratio will be adjusted properly, and your power dissipation is always there because your PMOS हमेशा on रहता है। You can see it is grounded together, 0 volt हमेशा दिया है तो हमेशा on रहेगा। So power dissipation is more. So that things we will do in the next lecture. So I'll just stop here. We will do that pseudo-nMOS in the next lecture. Okay, I just stop this here. So I think I hope everyone has understood transmission gate. If anyone has any doubt, so if I give any expression, any suppose if I ask you to implement AND gate, are you able to do that using transmission gate? Please apply. AND gate, OR gate, XOR XNOR तो देख ही लिया, even though transmission gate for the multiplexer also we have seen. So are you able to do that? Are you confident enough to do that? Okay. Others also please reply. And if you have any doubt, you can ask me, or otherwise you can proceed for the next lecture. Okay.